A ball is thrown vertically upwards from a point P, which is 5 meters above the ground with a speed of 20 meters per second. Find A, the greatest height above the ground by the ball, B, the time of flight of the ball, and C, the velocity the ball hits the ground. So here we've got a man, the ball is 5 meters, he throws it up, it goes up. Alright, so we're going to measure displacement from this point here, P, S, goes up, hits the greatest height. Now the greatest height, the velocity of the ball will be equal to 0, then it's going to go back down. Notice gravity is acting downwards, and that's therefore it's minus. Upwards is going to be taken as positive. So it's very, very important when you do this type of problem to get the signs correct. So the ball is affected by a constant acceleration, namely gravity. Therefore, we can use the SUVAP formula. So A will be equal to minus 9.8 meters per second squared, minus because it's acting downwards. U is positive because it's thrown upwards, 20 meters per second. And up the greatest height, as it goes up, the velocity will become 0 because the acceleration acting on it will slow it down. So V is 0 meters per second, S will be this distance here. That's the displacement. So using V squared is equal to U squared plus 2AS, we're going to have that 0, because we want the final velocity to be equal to 0, is equal to the initial velocity 20 meters per second squared plus 2 times minus 9.8 times the displacement. That gives me 400 minus 19.6 S. Taking the 400 over here, we get minus 400 is equal to minus 19.6 S. Therefore, S will be 400 divided by 19.6. The minus signs would cancel out, and we're going to get a displacement of 20.408. That means that from here to here is 20.48, but the question asks for the greatest height, so we need to include the 5 meters. So the greatest height will be equal to 20.4 plus 5, which will give me 25.4 meters. Now, to find the time of flight, so we want the time it takes to go to do that, S will be equal to minus 5, U will be equal to 20 meters per second, A will be equal to minus 9.8 meters per second squared, negative, positive. The final displacement is minus 5 because the ground is lower 5 from the starting position P. So using S is equal to UT plus a half AT squared, substituting in things carefully, we've been very careful about the signs here. S is minus 5 is equal to 20T plus a half times minus 9.8 T squared. So it gives you minus 5 is equal to 20T. A half times minus 4.8 is minus 4.9 T squared. This is a quadratic, so we should put it equal to 0 to solve it. So it means 4.9 T minus 20T minus 5 is equal to 0. Can't factorize, so we use the formula. So T will be equal to minus 20. Again, you're going to have to be careful with the signs. Plus or minus the square root of minus 20, so we're using good use of brackets, squared, minus 4 times 4.9, times minus 5 divided by 2a, which is 2 times 4.9. Minus 20 is 20 plus or minus 20 squared minus 4 times 4.9 times minus 5 gives me 498 divided by 9.8. So if we do 20 minus the square root of 498 divided by 98, we're going to get this. Now on the calculator, use the fraction button on your calculator. This is not possible because we can't really go back in time, and therefore T will be 20 plus square root of 498 divided by 9.8, which gives me 4.3179 seconds. So the time of flight will be 4.32 seconds to 3 significant figures. Now we're asked for the velocity the ball hits the ground. So taking U equal to 20 meters per second, A is equal to minus 9.8 meters per second squared, and the time of the flight is 4.3179 seconds. Now if we use v is equal to u plus at, we're going to get that v is 20 plus minus 9.8 times the time, which is 4.3179. So that gives me minus 22.315, which is minus 22.3. Now it's negative because the velocity is acting downwards, it's acting with acceleration. So notice the ball is negative because the ball is falling downwards. Now we could have used v squared is equal to u squared plus 2as, v squared is equal to u squared plus 2as, with s being equal to minus 5. We've got v squared is equal to 20 squared plus 2 times minus 9.8 times minus 5, which is 400 plus 98, which gives me 498. But because the velocity is acting downwards, we need to take the negative square root of 498, negative because the ball is falling downwards, which again will give me minus 22.315, and we get minus 22.3 meters per second, same as we've got up here. Now, if we were just asked for the speed, then it wouldn't really matter because we just give the answer as positive as 22.3 meters per second. So this has been a video about throwing a ball up into the air and then using the Suvat equations to find the greatest height, the time of flight, and the velocity at which the ball hits the ground. I hope you've understood, and I thank you very much for watching.